This is a flip video about specific heat capacity. When we're talking about heat, heat is just a form of energy. Or heat is one type of energy. So it's important to know some units of energy. We've got calorie and joule as the two units we're going to be using in this chapter. So a relationship between these units is seen here. 1 calorie equals 4.184 joules. This is a good conversion factor to write in your notes. Also important to know is that you could also have a kilojoule. So 1 kilojoule is equal to 1,000 joules. Okay, now what does specific heat capacity mean? Well, if we think about it, the word specific and heat and capacity. Well, capacity is an amount, a maximum capacity. It's how much something can hold. And so we're talking about heat. Heat capacity refers to how much heat how much energy something can hold. And when we talk about specific, we must be relating to different things. So specific heat capacity in a formal definition is the amount of energy that's required to change the temperature of a 1 gram sample of a substance by 1 degree Celsius. So every substance has a specific amount of heat that it needs to increase the temperature of a 1 gram sample of it by 1 degree Celsius. So if we kind of look here, these are specific heat capacities of different substances. They're constants. They'll be given to you. They're always the same when you talk about a substance. Each substance has its own specific heat capacity. For example, water at a liquid has a specific heat capacity of 4.184 joules over grams degree Celsius. Joules refers to energy per every 1 gram sample that goes up 1 degree Celsius. So that's the unit. And if you notice, I listed a bunch of other substances. If we look at this kind of in a picture form, I have here a cup and some water in it. And I measured it, and it's about 1 gram of water. And here's my mega thermometer. And let's say that the water's at 9 degrees Celsius. For the sake of argument, we'll say that that's still a liquid. And that I want to know how much energy do I have to put in to raise the temperature up 1 degree Celsius. Well, the answer is that is the specific heat capacity. Water needs 4.184 joules of energy going in to raise this 1 gram up 1 degree Celsius. Okay? And if you notice, water at different states of matter has different specific heat capacities. And then I've also listed some metals that are kind of popular that we'll be working with. All right, so where will we use specific heat capacity? Well, here's the equation that we're going to be using. And this is called the energy equation. And so if you notice here, I've got Q equals MC triangle T. And we call this the MCAT equation. And again, it represents the energy equation. So let's talk about what these variables mean. Q equals energy, either in joules or calories. M equals mass, which is in grams. C equals specific heat, as we just looked at, right? So these specific heat capacities will be given to you in joules over grams degrees Celsius. And delta T, which is triangle T, is known as a change in temperature. Change in temperature is taking your final temperature, minusing it from your initial temperature, and that's in degrees Celsius. So if I'm going to use my specific heat capacities seen here, energy is measured in joules, so this specific heat capacity value needs joules for energy. Okay? All right, now let's take a look at a sample problem. Determine the amount of energy, which is heat, in joules required to raise the temperature of 7.40 grams of water from 29 degrees Celsius to 46 degrees Celsius. So I'm no longer talking about 1 gram of water, rather 7.40 grams of water. The first thing I want to do is I want to list out all of my variables. So remember, here's my equation. Write that down. And let's list out all these variables and see what we have and what we don't have. So I'm solving for Q, which is energy, so I set that to X. I have a mass, which is 7.40 grams, seen right here. And then if you notice, I filled in my C, which is my specific heat capacity. Where did I get that from? Well, it's not mentioned in the problem, but remember, you need to refer back to all the specific heat capacities, right, seen here. And if you remember, C is what specific heat capacity, that's the letter that it stands for, right? C is specific heat capacity. So I find water on the list, and it's 4.184 joules over grams degrees Celsius. That's the unit. Okay, I fill that in, and then I do my change in temperature. Remember, this is my initial, and it changes to 46. So 46 minus 29, final minus initial. Don't forget sig figs. It's the place value after the decimal when you add and subtract. Okay, now I have all of my information, and I just have to plug it into my equation. So this is the Q equals MCAT equation. Q is what I'm solving for, and I got 7.40 grams for my mass. 4.184 joules over grams degrees Celsius is my unit. Don't forget units. And 17.0 degrees Celsius. We're not going to be looking at your constants, right? You're given right here. This is a constant value for sig figs. It came from a chart. Instead, we're going to be looking at the other pieces of information. So 3 sig figs here, 3 sig figs here. So my Q now should have 3 sig figs. And let's take a look at units. I've got a joule over a gram degrees Celsius. So this degree Celsius and this degree Celsius cancel out. If you notice, I've got degrees Celsius on the denominator, and here it's in the numerator. Same thing with a gram and the gram. So I'm left with joules, which is exactly what the problem asked for. So this is a good time to pull out your calculator and calculate this and see what you get as your final answer. That's the end of the video.